My boy Vince says, in the screenshot I sent, I don't understand how you used another x on both sides and how below that resulted in a negative 1x plus 4. Can you explain the whole concept around canceling out numbers? Well, yeah, canceling out numbers is not really a good way to describe what I was doing in this problem. This is actually a screenshot of a video I was making. So let's just take an equation. So if I had 5 equal to 5, right? We know that equation that works. Now, what I could do here is I could subtract a 5 on both sides. Let's not do subtract 5. Let's subtract a 1 on both sides, right? So I have 5 minus 1 and minus 1. So technically, we write that as 5 minus 1 is equal to a 5 minus 1. Now again, as long as I'm doing the same operation to the left side to the right side, that is our property of equality, then I'm still going to have an equation that is going to be true. So 4 is going to equal to 4. Now, there's a couple things that we need to understand. So that's why that's why I'm doing things on both sides of the equation. I think it's also important to recognize in this case that we understand, like if I have 5 minus 5, that is equal to a 0, right? That is what we call our additive inverses of each other. And in the same thing, if I did 5 divided by 5, that would equal to a 1, right? That's the multiplicative inverse. So 5 minus 5 is going to equal to a 0. Now, if I had a 5x minus a 5x, then again, that's going to equal to a 0x, right? Which is just also equal to a 0 because 0 times anything is 0. So let's go and look at the problem that I had. I had an x plus y is less than 4. Now in this problem, what I need to do is I need to isolate the y. Oh, that was the one last thing I wanted to do. So if I had an x plus 5 equals, I don't know, 9, right? So if I want to solve for x, that means I need to undo what's happening to the x. So if you read this equation, it says x plus 5, how do you undo adding 5? Well, you're going to use the inverse operation, which is to subtract a 5 on both sides. So x is going to equal to a, sorry, I was actually going over what I didn't want to do for you. So now, if I subtract a 5 on both sides, we write it like this, but technically what it's doing is x plus 5 minus 5 equals a 9 minus 5, right? You could also write it like that. This just saves some room here. So what is 5 minus 5? Well, that's x plus 0 is equal to a 9 minus 5, which is 4. Well, what is x plus 0? X. So x equals 4. So we say like subtract 5 on both sides, cancel out, but they're not really canceling out. They're just subtracting to 0, and x plus 0 is equal to x. So in the problem that I was talking about, the same thing here. Now in this case, we're trying to undo what's happening to the y, right? Now this one is not x plus 5. This is x plus y, but we want to solve for the y. Well, just remember, guys, multiplication is cumulative. So if I have x plus y, I can rewrite that as y plus x, right? So you can look at it this way if this makes more sense to you. So again, like if you need to get rid of the x, what do you need to do? You need to subtract the x. Okay, so again, I have a y plus x minus x is less than a 4 minus x. Thank you, MacJello, for the super chat. I very, very much appreciate that. Thank you so much. So in this case, I have a yx minus x. Well, again, just like it over here, like 5x minus 5x is going to be 0x. So x minus x is going to be a 0x, which is just going to equal a 0. So that's how I get the y plus 0 is just y. So less than a 4 minus x. And what did I do here? Oh, okay. And then what I did over here was typically I was going to rewrite the variables in front. So therefore you can just rewrite it like this, plus 4, right? Because that's a positive 4. So you can just rewrite it like that. I was teaching, so I might have skipped some steps for my students. That's why it might have been a little bit more confusing, but hopefully for this video, that helped you out from on